Hey, can I please have your attention up here?
So, Katoa.
Thank you. So today we're dealing with sine and cosine ratios. Yesterday we tangent. Okay, so a lot of the stuff is going to be very similar to yesterday. We talked about all the ratios yesterday, but once again, get your little phrase down. So katoa. All right. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. As I was walking around yesterday, I noticed that a lot of you had, rather than writing it like this, and I'm going to abbreviate today. So many of you, rather than writing it like that, you wrote it like this. You said sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. So katoa. Okay? You could also, remember, write it like this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So you got your so, your ka, and your toa. Tan is opposite over adjacent. Okay? I don't have any buy-in to how you write it, just that you remember those ratios. All right. So let's get those on there. There's your little comic for today.
I don't get it.
I know. You got to read it. I know. It says, like my Sudoku. I know. Sudoku. Okay. Are you sure you don't mean Sudoku?
I don't get Sudoku.
Wait, how are you not
so
offended by that
confusing.
one?
I'm not offended by it. It's fine, actually. Hey, that's 80. That's 9.
Nice!
What's that one?
That one. What?
Uh-oh.
Oh, I will find this.
Good job. What's that?
3.
It's not really 3. It's the wrong number. 3.
It's like that fancy 3 that means
3 times 2 times 1. That's what factorial means.
Oh,
Woohoo! All right, moving on. All right, let's try these problems together.
Stop talking.
Give yourselves about, these shouldn't take too long if we remember our ratios. Remember, just setting up ratios. Give yourself a minute, get those 4 done. Okay, here we go. Sine A, number 1. Hold on. All right, so we've got person number 28 in our class is, who's 28? Bennett, that's you.
Me?
Yep, Ben.
T 12 over 9 or tangent 12 over 9. Or wait.
So we're doing sine, right?
Yeah, sorry.
So we trace it. If we're dealing with sine, this side is the opposite of A. This side, what is this? This is adjacent. And I'm going to label it as A. And this is hypotenuse. Now, is it always the hypotenuse?
No. Yes. Yes.
Why is it always the hypotenuse?
Because no matter what.
Andrew?
it's always along the side and it's not on the opposite side.
Good. Now, you can only have a hypotenuse with a right triangle. This is right triangle trig, so this only works with right triangles. Okay, so we're dealing with sine of A. Then we're dealing with which ratio?
0 over hypotenuse.
Yeah, opposite over hypotenuse. And opposite is? Good. 12 over 15. Good. Now, if you want to reduce it, you can, right? We don't need to really right there, but we could. Okay, Mr. Winkler.
I just need to see Jody for a second.
Jody. All right. How about Kosei? Kosei. Oh, hold on. I'm calling on the people randomly. Number 5. That's Hannah Devine. Go ahead.
I got 9 over 15 or 3 over 5.
3 over 5, so that is adjacent over hypotenuse. 9 over 9 over 15 or 3 over 5. Well done. How many got that? Good. Okay. All right. How about sine B? Let's go with number 16, person 16. Riley, that's you. 9 over 15, yeah. So in sine B, it's opposite. This is opposite of B, and this is adjacent to B. Okay? So sine B equals 9 over 15. All right. Or 3 over 5. Okay, how about cos B? Cos B. 13, person 13 is Maddie. Maddie.
12 over 15.
Cos B equals adjacent of B over hypotenuse. Good. 12 over 15. Or? 4 fifths. 4 fifths, yeah. I put 3 fifths almost again. 4 fifths. Okay, questions? All right. Next one. Let's give number 9 a go. Number 9. Actually, let's do 9 through 11 there. Okay? Give those a shot. I'll be walking around helping out. Hey, can I get your attention up here? Probably poor instruction on my part because I didn't go back and remind you of a few things. 2 really good questions came up. First is, how do I know which of the 2 to use, sine or cosine? Okay, always look at the angle there you're dealing with. So here we're dealing with a 50-degree angle. So if I trace that angle, in relation to that angle, which 2 sides are we dealing with? Well, this one is our hypotenuse, and this one is opposite. Okay, so we're dealing with opposite and hypotenuse. And when we have SOHCAHTOA, which one is opposite and hypotenuse? Sine. So we're dealing with the sine. The sine of our angle, 50, is equal to opposite over hypotenuse. Now, the next question that came up was a really good one as well. Will that work for showing my work? No, that won't work because I need to see exactly what you're putting in your calculator. So I'm glad you wrote that down. I mean, that's the first piece. But I actually need to see the piece you're putting into your calculator, which most of you are putting in 15 times sine 50 equals x. So when you cross multiply, so I need to see the 15 sine 50. Those of you that borrowed my calculators, remember my trig students are using them right now, and they're dealing with radians. So make sure you're in the correct mode. You have to be in degree mode. Okay? So when we put that in, what do we get?
11.5.
Good. X is equal to 11.5. Yeah, approximately. But rounded to the nearest tenth. Okay, no units there, so you could write un, or you could just leave it blank. Any questions there? Very good. Keep on working. 10 and 11 there. Hey, how many are done with number 10?
Me.
Okay. Hey, the temptation, guys, I get it. The temptation is to not show as much work. Okay, but it's really important that you get the right thing down here. So if I were you, I'd first figure out which I'm using. In this case, it's adjacent and hypotenuse. Okay, so we're dealing with cos. It's cos of 63 equals adjacent 5 over x. Be careful if you're not writing down this step. Like if you're just skipping right to here, and you're excluding this, you're like, well, McCoy doesn't need to see this. He just wants to see this part. That's fine, but you better make sure you do it right. If you go 5 cos 63, you got the wrong answer here. Okay, when you cross multiply this, you end up with x cos 63 equals 5. And then you have to divide both sides by cosine 63. Okay? The less work you show, the easier it is to make mistakes. Okay? 5 over cos 63, I don't know what that is. 11 point what?
0.
All right. Approximately 11.0. Okay. Any questions there? All right. I'm not going to work out 11. I think you guys are good there. Okay? Anyone have the answer for 11?
16.
Eli, what do you got? 16.5, is that what you got?
Yep.
All right, so it's 16.5, it sounds like.
Not myself.
All right,
Good.
for those of you who want to check it later. Okay? If you got it wrong, maybe call me over. All right, try looking down at number 15. Remember, when we're dealing with inverse sine and inverse cosine, those are trying to find angles. Okay? So if we're trying to find the angle, we use the inverse function. If we're trying to find sides, then we use the actual sine and cosine functions. Okay, so why don't we try number 15, number 16 there. We might get to 17. I'll be walking around helping out if you're confused. Okay, hey, I had four of the same question. All about this. And each one of you, very well done, you knew that we were dealing with which trig function here? Sine. Yep. Okay, so we have the sine of x, and each one of you actually, once we started talking about it, you're able to pick it up. So 15/20 here. When our variable is here where the angle usually is, that's where we say, well, we need to get rid of the word sine. We can move that over, kind of relating it to your prior knowledge. Mathematically, this isn't how it actually works. If you move that over, you're saying x is equal to, when you move the sine over, it becomes the inverse of sine. The inverse sine of that 15/20. Okay? So the inverse sine of 15/20 is? What is it? 48.6. And degrees. Good. So that's rounded the nearest tenth there. Okay? Let's try 16 and 17. Okay, since we're dealing with adjacent and hypotenuse, we have cosine of x is equal to 11.3 over 15. So x is equal to, we move that cosine over, it becomes the inverse cosine of 11.3 over 15, which gives us x equals 41 point, is it 1?
Yeah,
1 degrees. All right. Very good. Hey, any questions there? I'm not going to do the next one. I think you guys are good. Your assignment is your mixed side. Mixed side. Woohoo! I'll be around helping out.